Welcome back. Well, I was going to talk about physics, but why? No. We can talk about physics. I'm pretty sure I pretty much covered the gist of all basics and inquiries on the first two videos. Since then, I have doubled back and notated down all of the different particles and atoms and so on and so forth. Just too late. Okay, so one other thing that I wanted to absolutely get across first, if you don't want to watch the rest of the video, that's cool. Dark matter is a category of particles. Gravitons are part of that category. Sorry to break it to you. Very true. Where are you coming up with this information? Well, it doesn't matter where I'm coming up with it per se, because I know. Make sense? Savvy? Okay, good. 3 frames back, 1 frame forward. Here we go. I'm not sure if I touched the subject very much as far as explaining it in the previous 2 videos. Here's another explanation. I'm going to try to keep this video as short as possible so that it actually uploads instead of pisses me off for the next 5 weeks. First thing we have to agree on. The first thing we have to agree on is that space is not necessarily empty, like most people expect. Granted, when you are in a galaxy that is surrounded by very little space, maybe some other galaxies, maybe some nebula here and there, a whole lot of stars, so on and so forth. What you're really in need of comprehending is that you're in a realm, and the more you argue with me, the more fucking annoying it is. Seriously, I'm really recording. I'm psychic if you didn't know that, by the way. But anyway, it's one of the requirements. Stuff like that. Family name, family tree, whatever. Like it's family tree. I like to be laid back. I don't like to talk about physics like a tightwad, you know, with my glasses on and my bow tie and my button up, all tucked in, all nice and cute and mocked. Anyway, like I was saying, space is not necessarily empty. Firstly, you have to recognize that any amount of space which held universe or galaxy which fell apart, exploded, collapsed, etc. over time is essentially strained. It is like a strained muscle or a hair tie or rubber band that you overstretched, and now it has one of those no longer elastic or rubbery natured gaps in the middle of it, and it's no longer returning to the size that it was. You understand that very well? Okay, so we have this megastar. It has this big energy field, and that energy field is essentially the surface, which glows and resonates light and shines light on everything else, blah 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 blah. The light is the field. The light is part of the projection of the field. There's essentially a limitation to how far that light can travel before it is recollected as an energy by said planet, star, moon, etc. that its light is touching or reaching, or which is within the field of the capacity of the light's ability to travel. And as you may very well know or not know, gravitational fields and magnitudes do affect light waves and any kind of wavelength signal which travels through space or across a distance and has a velocity. So what I'm telling you is that there is a limit to how far that light can travel without essentially being a glow instead. Now, why does that happen? Very similar to strains. The capability of your eye to perceive what is there and the distortion of time because of the distance, which causes you to not know that a star exploded until maybe even millions of years after, even though you were using a telescope, is essentially the same as, it's not the same, it's similar, not the same, to if you were to contain an atom inside of a shell which was elasticizable, or you could stretch and it would not lose its airtight capability or particle tight capability. Is essentially a true vacuum, real vacuum, which would be called a void, which that shell would be called a void. So if you contain an atom in that void, and that void is very compact, maybe just the size literally of the fingered hand gesture that I'm making right now, and then you were to stretch that void, that shell, and it created that vacuum effect where, you know, if you put a marshmallow into a vacuum chamber, the marshmallow swells, the atom will swell as well. Once that atom reaches beyond its strain points, there are many levels for some atoms. Either the entire field will essentially change in nature, so as to say, you're using an atom of hydrogen. The nature of hydrogen is that it's slightly flammable, it's usable as a fuel in comparison to more flammable combustible substances. Hard to describe because the table of the table of elements, whatever you want to call it, so finite here. It has that specific nature. The hydrogen has that specific nature, and beyond that strain point where it's expanded because of the vacuum, the void, and it has the nature to fill that void. Once it reaches that strain point, essentially there are a few things that can occur depending on what kind of element, what kind of atom, what kind of particles, like quarks and what was the other ones, bosons, fermions, stuff like that, photons, blah blah blah, neutrinos. names come up all the time. Anyway, within that void, there is a limit that atom's field can extend. Once you expand that atom in the void beyond its extent, it is essentially strained. Beyond that strain, particles within that atom's field are then what are being pulled away. So the core of the atom is holding more particles than the exterior, which holds the field together. Once you reach that strain point, then you have some freaky occurrences which could happen. Either those particles in the core could, faster than the speed of light, extend beyond that strain point or that extent or that limit that the previous field described can reach, and therein there is another field which causes that trippy looking different color thing, whereas you shine specific light on the material in the field, the material reflects a certain color. So basically what you're doing with this void is you are opening Pandora's box. You have no idea what's going to happen unless you know exactly what is in that atom, what particles are there, what those particles have remnant atonement for as far as being part of other elemental compounds, what their congruency or ability to fit into those compounds and form those compounds or maintain those compounds, etc., does when it is essentially returned back to a state that it previously was before attaining those congruency qualities. So essentially, straining an atom can theoretically take that atom back through time, through its existence, and return it to states that it once was before. However, on some other occasions and other elements and other particles, doing that activity could cause incredible explosions. Cataclysmic explosions. Do not play. Okay? It doesn't matter if you think you have just one little molecule of uranium, and it's okay because it's just a small amount. That very small amount of uranium could cause such a cataclysmic explosion that it could destroy the entire galaxy. And that was just an example. I'm not saying that uranium's that dangerous. Probably shouldn't play with it that way in the first place. Most often in scenarios like this, the scope of materials is very delicately handled and nitpicked for available use and study and so on and so forth. Just like being a physics professor or a chemistry professor, you don't hand your students or your unknowing peer the doomsday stick, right? Okay. So, essentially, in other words, compound elements or so on and so forth, which are formed over time, like, I'm going to say uranium again, blah, 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 off of other elements and particle activity and so on and so forth. like I was saying before, could be taken backwards through its time as an existing particle by way of using the void vacuum method. However, that method is very difficult because you would be amazed at the size of the vacuum that you would need in order to accomplish that goal. Also, picking and poking at an atom while it is beyond its strain point can be dangerous as well, because you are interfering with essentially the processor, the core of the atom, and even if it is a non-explosive material, you could cause an explosion. This is why these types of things are not supposed to be told or taught or whatever. But so if that was all theoretical, congratulations. You can turn away and be like, well, I want some of what he's smoking. No. Also, like I was saying, a star explodes. Oh, the explosion is so powerful that the energy field and the glowing, resonating heat and energy and iridescence, or whatever word you want to append to the material, looks like it's frozen in time. It looks like a splash of light that never stopped glowing, or blah 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 blah. That's true. It's very, very truly possible. What you can recognize about that is that there is the field which holds the energy, and then there is the second. That is the primary field. The secondary field is a light wave type, which allows amongst all of the darkness for the glowing object to be seen from afar. It's kind of like a relay field where the glow is relayed as an image, so to speak. That can be distorted as well. And that could cause, those phenomenon things like the Naga lights, or when you think you see a spaceship in the sky that looks just like a star, but then you think it's a star that's moving really, really fast, and you're like, what the fuck is that star doing? But what it is that the field is being distorted by the magnitude of some other object or star, or moon or planet or asteroid or debris. Basically, the capability to distort the light field is the same as the capability for magnitude or gravity to distort your standard wavelength traveling ray or signal. Whereas, if you put it this way, you have a signal. This is really difficult to explain without little trinkets. Alright, so you have Earth, and then you have a signal coming from Earth. As it gets close to the moon, the moon's like out here, right? And its signal's going this way, or whatever, past the moon. And let's just say the signal's traveling like this, but we'll do it like this. The signal is traveling past the moon, and as it gets closer to the moon, the signal crest wavelength heightens, and once it gets past the moon, because it's powerful enough to get past the moon, it comes back to regular wavelength, height, and crest. That would be the attraction factor. The repulsion factor would be that which literally, more often than not, destroys your signal or wavelength. So instead of your wavelength traveling this way and getting bigger, you have your wavelength getting pushed around and all kinds of bullied as it's trying to get past. Two possibilities. 20 minutes. The sheer fact about sending a signal is that you have to generate a field around your signal to maintain that signal, or else your signal is going to be so distorted that it is not going to carry the message that you are intending for it to carry. And that's where I'm going to end this video. I'll come back to another one later, but I'm going to try to upload this before it gets to 25 minutes, see if it doesn't crawl in my skin and not upload or something like that, but we'll see where it goes. Alright, have a great day.